Welcome to Key Equivalent Handling in Cocoa Applications. My name is Peter Ammon. I'm an engineer on the Cocoa Frameworks team. Before we begin, I must confess that the title of the session is a little incomplete. The first half will indeed be about key equivalents in Cocoa applications, but the second half will bring up my colleague, Raleigh, who will show you how to create custom views and menus, for example, the Finder label view, or also entirely simulated menus, like the suggestions pop-up in Safari. So you won't want to miss that. So we're going to cover the basics of key equivalent handling. What are key equivalents? How do you set one? We'll go over the keyboard event flow. So when the user actually types a key event, what methods get invoked, and how can your application involve itself with that? We'll talk about handling key equivalents from other applications, so you can respond to events when you aren't even the frontmost app. We'll go over conflict handling. What happens when two menu items claim the same key equivalent? Which one wins? We'll go over how to debug these conflicts when they occur, and then I'll bring up Raleigh for the custom menu items and simulated menus. So, key equivalent basics. Well, key equivalents are there to accelerate access to commonly used menu items and buttons via the keyboard. So here we see the save button, which has a key equivalent of return, which is why it's showing blue. And we have the new menu item, which has a key equivalent of Command N, of course. And it's the same API on NS button and NS menu item, but most key equivalents are on menu items. Now, programmatically, we refer to the N that you see there as the key equivalent, and you can set that with the setKeyEquivalent method. Now, notice that the N we pass is lowercase, even though it draws as uppercase in the menu item. This is important. It will draw uppercase even though you pass a lowercase string. If you passed an uppercase string, it would, in fact, interpret it as if you were requesting shift as part of the modifier mask. So you want to stick to lowercase characters unless you want the shift key. Now, the command key you see next to it is part of the modifier mask, of course. There's 4 different modifier flags that are available. There's command, option, control, and shift. You can also pass nothing at all. It's perfectly valid to have a key equivalent with no modifier mask. You may be wondering about the function key. A lot of keyboards have that, but in fact, that is not supported. A good reason for that is that not all keyboards have that, so those key equivalents will be unavailable to those users. And again, this is to set the key equivalent modifier mask, of course, you call setKeyEquivalent modifier mask, and you pass a bit mask of the modifier flags that you would also get from NS event. And this is the same on NS button as it is on menu item. Now, you can set these programmatically, but most of the time, of course, you set them in Interface Builder. Here, the new menu item is selected, and down to the lower left, you can see the portion of the inspector where you can set the key equivalent. So which items should get key equivalents? Well, you want to assign them to frequently used commands. And in fact, the HIG lists a lot of key equivalents that have standard established meanings. And I mean a lot. There's a lot there. It's very comprehensive. You want to try to avoid repurposing these standard or reserved key equivalents because users expect them to behave consistently across applications. Now, a very powerful technique for enabling power users is to use an alternate menu item. This is, for example, close all. Close all appears when you press the option key. That's why it's called alternate. And this doesn't clutter up the user interface. But because these items aren't very discoverable, you have to know what to press, you always want to provide another way to accomplish the task. For the example of close all, you can, of course, just close each window individually. Now, it's worth noting that the key equivalent you set may not be the one that appears. And one reason for that is what's called user key equivalents. These are things the user can set in the system preferences. So here the user is setting Command Shift C as close for the text edit. This is called a user key equivalent, and you can access it with the user key equivalent method on the menu item. So we actually expose when this occurs, and you can get what the currently selected user key equivalent is. So those are just the basics. What happens when the user actually types an event? Well, event handling always starts in NS application send event. That is the earliest point at which you can catch an event. And it's worth noting in this diagram that I'll show you, every orange box represents a point at which your application can override. It's an override point, so you can involve yourself in event handling. And the first thing a send event will do is invoke what are called local event monitors. So here's an event, and local event monitors, they can just pass the event on through, they can handle it, or they can return an entirely different event. So in this case, the event goes in, and it comes out, and you can see it's entirely different. It's a different color. So let's say that the local event monitor does not ignore the event. It returns it so it can continue being processed. Now, the next step, whether the event contains command or control, is an important fact in how the event is dispatched. If it contains command or control, it's going to treat it like a key equivalent first. So it's going to call perform key equivalent on the key window. So before it even reaches the main menu, it will start on the key window. And the default behavior of perform key equivalent is to call perform key equivalent on all the views, and this is recursive. So if you wanted to do a custom key equivalent on a view, you could override perform key equivalent. Now, assuming none of the event is not handled by perform key equivalent, it will also try other active windows. What do I mean by an active window? I mean a window such as a drawer attached to the key window, or a sheet, or the main window if it's different than the key window. But in this case, it only calls perform key equivalent on views that manage menus. That specifically are pop-up buttons and segmented controls that have menus. So for example, a pop-up button in the main window can handle key equivalents. And this is recursive in the same way. Now, if perform key equivalent returns yes, that's a way of indicating that the view handled the key equivalent. And if it returns no, it indicates it doesn't, and the recursion should continue. So let's say that the key window didn't handle the key event, and neither did any other active windows. Finally, we reach the main menu. Perform key equivalent is called. And normally, to do dynamic key equivalents in the main menu, you want to implement delegate methods. A very tempting-looking delegate method is menu has key equivalent for event target action. This allows you to return yes as if that it does have a key equivalent, and no that it doesn't. And this looks tempting, but in fact, this is a problematic method for a couple reasons. One of them is that if you just dynamically say yes, it had it, or no, it didn't have it, we don't know what to draw in the menu item. And it doesn't get called if the menu is opened. So if the user opens the menu and then types a key equivalent, this method will not get called. And lastly, it doesn't work by default with user key equivalents. You'd have to go to heroics to make user key equivalents work with this type of delegate method. But it has one good use, and that's to suppress expensive population for menus without key equivalents. So for example, the open recents menu, it has to hit the disk to be populated. You don't want to do that every time the user presses a key, so you might implement this delegate method to just return no, which is a way of saying don't even bother populating me for key equivalent searching because I promise I don't have any. Now, a better method to implement is menu needs update. This is called not just for key equivalent handling, but also when the menu is opened, when it's searched for accessibility, when it's searched with Spotlight for help. So it's called in a number of places. And your delegate method should populate the menu with the menu items and their key equivalents. And then the frameworks will actually take responsibility for determining which items match the key equivalent, if any. So the onus is lifted off your application for determining which key equivalents match. So far we've been assuming the event had command or control in its modifier mask. What if it didn't have those? Or what if perform key equivalent returned no? So it's not recognized as a key equivalent. So I'm going to take off the command key. Well, this is where the next step is that app command hotkeys are handled. So these are keys like command tilde for window cycling, or there's keys for moving the focus to the menu bar or to the toolbar. Now, other hotkeys that you might register for with a register hotkey don't actually get invoked via this path. In that case, the event is never even sent to the frontmost application. It's sent only to the app that registered the hotkey. But for these sort of app command hotkeys, these do get sent to the app at this point. And finally, we reach send event on the key window. And the key window is going to call key down on the first responder, for example, a text view. And the default behavior is to call key down up the responder chain until we reach the window itself, and it's window key down. And at this point, the default behavior is to call perform key equivalent. Now, if this is an event without command or control, this is the first time perform key equivalent has been called. If it did have command or control, this is in fact the second time, but most of the time it wouldn't get that far. And if the perform key equivalent on the key window did not return no, then it will call perform key equivalent on the main menu. So again, this might be the first or second time that perform key equivalent is called, depending on the event. And the very last thing it does is it will beep, and then the event is destroyed. So this is the very fallback behavior. So that's lots to take in, I know. But these are the things to keep in mind. Windows get first crack at key equivalents before the main menu. Now, if the event has command or control, it's treated like a key equivalent first. Perform key equivalent is called before send event. Other events perform key equivalent is called after send event. So the best practice is to do dynamic key equivalents. If you want to apply them to a menu, you would implement menu needs update to just install the menu items with the key equivalents. If it's on a view, you would override perform key equivalent. Now, if you want to do your special work before normal key equivalent handling, you can override NS application send event, NS Windows send event, and NS Windows perform key equivalent. Or you can call and install a local event monitor. If you want to do your special processing after all the other work is done, you could override key down on NS Window, and you call through to super. So that's how you handle key events within your own application. How do you handle them from other applications? Well, a very powerful and polite way to do this is to use a service. We see here's a bit of the services declaration from Stickies. Notice it declares a key equivalent of Y. And because it's uppercase, it will actually be Command Shift Y. This is very powerful because your app doesn't even have to be running. The frameworks will launch your application for you. And users can customize this in system preferences. It's polite because if the frontmost application also uses the key equivalent that you want, the application will win, so you won't interfere with the frontmost app. And you can also interact with the text selection. Stickies will create a new sticky with whatever text is selected. And to do this, of course, you specify the NS key equivalent key in the services declaration, like we see here. And I recommend seeing my talk from last year about services for more information. Now, another very powerful approach is to use a hotkey. And your application has to be running to use a hotkey. And hotkeys always take precedence. So it's very possible to register for a hotkey for the letter N, and then any type the user types N in any application, it will get sent to your app instead of the frontmost app. So that would be a rude thing to do. This requires a virtual key code, so you can't just pass the string N. You have to pass a virtual key code. You can find many of these in the events.h header in HI Toolbox framework. Or another technique is to actually ask the user, type the key event you want to be the hotkey, and then you can pull out the virtual key code from the NS event with the key code method. Now, to install a hotkey, you use a register event hotkey function. This is a Carbon function, but unlike many Carbon functions, this one is available in 64-bit, which is nice. The third option is to use a global event monitor. This is sort of the analog to local event monitors. They asynchronously respond to events, and they don't block events. So a hotkey will actually swallow the event, whereas the global event monitors will just allow you to observe them. To do this, you use add global monitor for event matching mask and handler is a block that you pass when you want your to be invoked when the right event is dispatched. So on to conflict handling. Most key equivalents are always visible, right? Close just shows Command W all the time. And some of them can be revealed, such as close all, when you press the Option key. And some of them are just sort of power user secrets, like you can hit Escape to close a dialog with the Cancel button. Now, when the key equivalents are visible, it's really important that what you see is what you get. What do I mean? Well, imagine an application like this with delete and duplicate both showing Command D. User types Command D hoping to duplicate, instead it deletes something. That's bad. This may seem like a very contrived example, but if the menu items are in very different menus, maybe one's in a pop-up, who knows, it could be confusing. So when two menu items claim the same key equivalent, NS menu will actually mediate between them to determine which one wins, and the other menu item will not show that key equivalent. And you may think, I designed my app, I picked all the key equivalents, I know there's no conflicts, but as we've seen, key equivalents can come from other places. They can come from a service, they can come from something the user requested as a user key equivalent. If your application has plugins, they can come from there, input managers, and any future menu items added by AppKit, such as close all. Now, they're first come, first serve, meaning the first menu item that requests the key equivalent will get it, except that user key equivalents always win. We respect the user's wishes, and services always lose. because they're very polite. And a surprising fact is that the key equivalent method actually returns the currently applicable key equivalent. So if I call set key equivalent when I pass n, and then I call key equivalent to get it back, and I get back the empty string, that's a good hint that some other menu item has claimed that key equivalent. Now, the n I passed isn't lost. It's just sort of dormant in the menu item. And when the winner goes out of the menu or it changes its key equivalent, my item will, its n will become prominent, and then it will return it from the key equivalent method. So I'll give you a demo of the conflict handling. So here I have a simple application which shows some files. I can get info on a particular file, and I can edit it. You'll notice that getInfo contains command I as the key equivalent. Now, command I is also used for italics, right? So in the font menu, you can see that bold and underline have their normal key equivalents, but italic does not. This is because the getInfo item got to it first. Now, if I open this file, you'll notice that getInfo loses its key equivalent. Where did it go? Well, if you remember that key window gets to try key equivalents before the main menu, and in fact, this key window has a pop-up button which has key equivalents in it, and you can see that italics goes to that, is in that pop-up button. And if I hit Command I, in fact, it does do italic instead of getInfo. Now, you'll also notice that the italics menu item also has Command I, which should be surprising because I said that key equivalents can't be shared. So we'll talk about how that works. And if I go back and make this the key window, getInfo recovers as key equivalent, and italics loses it. So the winner can be determined very dynamically. So as we saw with italic, sometimes it's OK if two menu items share a key equivalent. It's OK when they sort of do the same thing. In that case, there's no confusion if they both show it. To indicate to AppKit that it's OK if these two menu items have the same key equivalent, you can give them the same action. They don't need the same target. They just need the same action. And that's true, as we saw, even if one is in a pop-up and the other is in the main menu. They can be widely separated. So debugging. Often, as I said, you'll set a key equivalent, and then it doesn't show up. Where did it go? Well, another menu item has it, but where? How do you find out? Well, this is an important enough question that we'll share a bit of NSMenu's internals. Here it is. You can actually access the uniquing properties, the main menu uniquer, and print out as contents to figure out, OK, which menu items have which key equivalents registered. This is, of course, for debugging only, because absolutely this is going to change in the future. Hopefully it'll become easier. But for now, this is a powerful way to solve this problem. I'll give you a demo of that. So I've launched this application in GDB over here. I'm going to pause it. And I'll call what I said, NSMenu KE uniquer, main menu uniquer, print contents. And it outputs a lot of information. And we're looking for italic, so I'll search for italic. And there it is. And you can see that italic is registered for Command I, but so is getInfo. And getInfo is ahead of it, which shows you that getInfo is the winner. And that's why getInfo has the key equivalent and italics does not. So that's a powerful way to debug conflicts. So that is the end of the key equivalent portion of this session. I'm going to hand the podium over to my coworker, Raleigh, who will talk about how to create custom menu items like Finder's label view and how to simulate menus when you need the ultimate in flexibility. Yeah.
Thank you, Peter. My name is Raleigh Ledet. I'm a coworker with Peter on the Cocoa Frameworks. So it's custom menus and simulating menus. We're kind of switching gears here. So let me give you a couple of examples, the things that we do in OS 10 today, and I'm going to show you how to implement those things yourself. This is a menu from the Finder. Hopefully you're familiar with it. And this particular portion is you could set the label color that you want for your files. This isn't just a text. This isn't just some text in the menu. You can actually select little colored boxes. And they've done this by putting in a custom view inside the menu. And we'll go ahead and show you how to do that yourself. Sometimes, though, menus aren't quite what you need. And so far as example here, when you start typing a location, it puts up a custom list of suggestions. The problem with having this in a menu is that focus is actually still on the text field. And the menu wants to focus for itself, and so that won't work, and you can't put up a menu. So you actually have to simulate a menu. So I'm going to show you how to do that as well. So we have some sample code. Hopefully you've already downloaded it. If not, you can find it there. And we'll give you a quick tour of what the sample code does. So right over here, we have a custom menu items. And you see it has a normal regular menu item here, and we can track around. And these are just pulling images from the desktop images. And we can also search for them here. We can type IL, and we see a list of suggestions, and we can choose a suggestion, or we can change that. And here's all of the L items, and maybe we want the ladybug instead. So this is the sample code, and we'll show you how to do both of those items. So first, let's talk about custom menu items. Whenever you can, it's preferable that you actually create a custom view and put that in a menu when what you really want is true menu behavior. This is the most appropriate way to do it, and the most future-proof way of accomplishing that. And so this is our analog to what they're doing in the Finder. It's the exact same thing. We've got a custom view with 4 images. And so the first thing you need to do is you need to create your custom view and set it as the view that the menu item should use. So Interface Builder, and I went ahead and I created a custom view with 4 image wells. I also put in 4 progress indicators, so the progress indicators will spin while we're waiting for the thumbnails to be generated. Then the other thing that you need to do, which is really important, you actually need to go in Interface Builder and the properties and set your class for your view to some custom subclass that you're going to write. You need to write a custom subclass so that you can handle the mouse events and the keyboard events. Now that you have a custom view, how do you put that custom view into the actual menu item? It's actually fairly easy in Interface Builder. You can drop down your menu, pull up its properties, and then connect the view outlet right to the view. Now when you run your application, instead of item 2, it'll put your custom menu item in there, your custom view. That's not the route I actually went in the sample code, because I actually look at that source folder. You saw there was one menu item where you could select a folder to be a source of images. And there's 4 images per menu item, so I dynamically add menu items as needed. And so since I do this dynamically in code, there's an API call on NS menu item called setView. All you have to do is call menu item setView, and you add your view. And now when the menu is displayed, your view will be shown there. So now that we got our view inside our menu item, it's coming up correctly. Let's talk about mouse navigation. Now, hopefully you were here for the previous talk that Troy gave, and he talked some interesting hints about mouse navigation. And a lot of people go into tracking loops, or you override mouse down, mouse dragged, and mouse up. We don't want to do that in this case for this application. Particularly, we don't want to do a tracking loop because the user can track from your menu item to other menu items. And for that matter, the user might press the mouse button down and keep it held down while we pop up the menu, drag to the menu item they want to select, and then let go. So you might not ever get a mouse down anyway. Instead, we're going to go ahead and use update tracking areas. We're going to create tracking areas to do our mouse tracking. And you do that by overriding update tracking areas in your custom view. In this case, we just loop through each one of our image views. And we're going to call an internal method that we'll get to in a little bit called tracking area for index. And the key important thing in this slide here is you call self add tracking area. So add tracking area is an API on NSView. And that's how you add your tracking areas once you've created them. Here's the internal method inside this custom subclass called tracking area for index. And we have to do a number of things before we actually allocate our tracking area. And the first is that I create a dictionary to hold the index that this tracking area is for. And this index I've just used so I can correlate which is the image view that this index is associated with, what's the spinner that this index is associated with it, and more importantly, what's the URL that's associated with this index, which is actually what other parts of the application are looking for. So then we go ahead and we grab our view that's associated with that index, and we convert its bounds to the coordinate system of our custom subview. And then we have to figure out what our tracking area options are. As I mentioned earlier, the user can drag through your menu item to other menu items. So you'll want to get your entered and exited tracking area events for both mouse moves and mouse drags. So we add the NS tracking enabled during mouse drag to our options. That way we'll get them in both cases. We want both the mouse entered and the mouse exited. We want to see whenever you come over one of the image views and whenever you leave it, so we update our selection properly. And then the last option is an NS tracking active inactive app. When the menu is up, your app is active. That works great. And if anything happens that's going to require your app to lose activation, the menu is going to go away anyway. So that's a nice little option to add on there as well. Now that we have all of that figured out, we can go ahead and call NS tracking area alloc, init with rect, the tracking rect that in our local coordinate system that we determined earlier. The options that we figured out up above, real important, make the owner self so that your custom view receives the mouse entered and mouse exited events. And then that dictionary that we created at the beginning as the user info, and this will allow us to associate the view, the spinner, and the URL that's all associated with this tracking area. So now that we have our tracking areas implemented and they're in place, and they automatically get updated whenever the system thinks that they need to be updated, we can go ahead and implement our mouse entered responder method. And so you could just call user data right off of event, and this will be that user info dictionary that we added to the tracking area. We'll grab our index value out of there and just set our property selected index to that index. I'm not going to show you the code for it, but in the implementation, I've actually created a custom set selected index setter method for this property. And in that setter method, I make sure that whenever the index changes, that I call self set needs display. That way, at any time, for whatever means that the index changes, we know that we need to redraw with the proper selection. Then we implement the mouse exited responder method. We don't need to look at the user dictionary in this case because the user is gone out of our tracking area, so at this point we have no selection. We'll receive a mouse entered if the user moves with the cursor into another image view inside this menu item, so we can rely on that and just return no selection here. Set our selected index to no selection. Now, we're not implementing mouse down or mouse drag, but it is important that we implement mouse up. When you get a mouse up event in your custom view, you'll only get that when the user has actually released the mouse over your menu item, your custom view for the menu item. If it's any other menu item, you won't get the mouse up. So now that a mouse up has occurred in your menu item, we obviously want to go ahead and send the action that's associated with that. And here's what we do when we send the action. There's a method on NSView called enclosing menu item. If you're associated with a menu item, and of course in this case we are, it'll return for you the menu item that you're associated with. And in this case, I call NSApp send action, and I actually get the action and the target that's already associated with the menu item that was wired up in Interface Builder, so I didn't have to do any additional work here. I could just wire it up in Interface Builder. Now that we've actually sent the action, we need to go ahead and cancel tracking for the menu so that the menu dismisses. And for menu item, we can ask for its parent menu, the menu it's associated with, and then just call cancel tracking on that menu. That's all you really need to do for mouse navigation. It's very simple. But now we also need to handle keyboard navigation because, of course, the user can navigate with the keyboard as well. And I'll give you a quick demo of that. So here we have the custom menu application. So I'm going to move the mouse way over here. So not using it. Everything's going to be keyboard driven now. Oh, okay, maybe not. There we go. Mouse is out the way. And so, of course, I can navigate with the keyboard, move around. I can jump to the beginning and to the end, usually. You can hit the space bar, return, and the item is selected. And, of course, you can just hit escape and dismiss the menu. There we go. So let's see how we handle that in code. So if you're here for the last talk, then you already know that you're not going to receive any keyboard events until you override accepts first responder and return yes. By default, NSView returns no. So we need to become first responder. Once you've informed Coco that you do, in fact, accept first responder, you will at some point be asked to become first responder. There are two cases that you might become first responder. The user has arrowed, navigated into your view via the keyboard, or perhaps the user clicked onto your custom view inside the menu item. If it's a user click, then we've already set the selection based on the tracking areas. So if there is a selection, we don't want to override that. But if the user arrowed into the menu item via the keyboard, then we don't currently have a selection, but we want to set the selection to something so that the user sees that is the item that they're manipulating at the moment. So in this case, we just set our selected index to 0. If you want to get really fancy, you might remember the last selection that was there on the menu item, so when they move to it, you move to the last remembered one. Since you can become a first responder, at some point you're going to be asked to resign first responder. Generally, they're moving off with the keyboard, or perhaps the menu is getting dismissed. If the menu is getting dismissed and your item was the one that was activated, at this point we have already sent the action, so setting the selected index to no selection doesn't do anything. But if we're resigning first responder because of keyboard movement, then it's important that we set our selected index to no selection so that the user doesn't get two highlighted items inside the menu and get confused. Now, finally, we can get a key down message, and we're going to do the typical Coco thing of just call interpret key events. This will allow key bindings to kick in and look at the key event and figure out what is the user's intention. And what's real important in this example, what's kind of unique, is that after we call interpret key events, we still need to call super key down so that eventually it will go up the responder chain, and in this menu can handle the key events that we don't handle. So key bindings is going to look at the event, and if it's the right arrow or the left arrow, it's going to call move right and move left on our view. This is great, so now you don't have to figure out what the key code is or the appropriate character for the right arrow key and the left arrow key. It's taken care of for you. So here we just move our selection right or left. And likewise, the user might do command right or command left, and that'll be interpreted as move to beginning of line. So you could move your selection to the end or the beginning in the sample code's case. Then, of course, if the user hits the return key or the enter key, we'll want to go ahead and send the action. They've committed it, so we can do send action, and we've already taken a look at that implementation. But we also want to activate our menu whenever the user hits the space bar. And traditionally, key binding just thinks of space as being part of text, 'cause it's usually associated with the text field. So there's no user action associated with space. So when key bindings doesn't find some action associated with that, it will call insert text. So we override insert text, and we look for the space string that has to be inserted. And if that's the case, again, we want to go ahead and send the action and commit that item and dismiss the menu. Now, the way key bindings actually works when you call interpret key events is that once it figures out what the command is that it wants to send for an action, it calls do command by selector on your view. And by default, this will find out, the default implementation will determine if your view responds to selector. If it does, it will call that. If not, it will route up the responder chain appropriately. And if it goes all the way to the end of the responder chain and nobody has responded to it, you will get the system beep. In menus, whenever there's some invalid keyboard movement, they don't beep. So we want to go ahead and just check for the selectors that we've implemented above. If it's one of those selectors, we'll go ahead and just call up to super, which will call back the correct method. But if it's not one of those methods, we specifically don't want to call super so that we eat the action right here and we don't have a system beep. Now you might be wondering, well, if we don't allow this to call up to super, then how can you navigate up or down off of your menu item? Well, remember previously when we implemented key down, after calling interpret key events, we called up to super key down, and that's why it's perfectly fine to eat this here and not worry about it. So now we've got menu navigation via the keyboard, and we can navigate via the mouse. You might want to throw some animations in your custom menu item. Now, you don't want your animations just running wild while the menu isn't even showing. That's a waste of resources. but you can override view did move to window. And the way this works is whenever we show a menu, we create a new window and we add all the menu items in there. If you have a custom view as your menu item, that gets added to the window, and we'll get a view did move to window call. You could check your window property from self.window. If you have a valid value, you can start your animations. When the menu is dismissed, we deallocate the window after we've pulled out all of the menu items, and including removing your view from the window. Your view is not going to be deallocated or released because it's actually still being held onto by the menu item. However, you'll get a view did move to window, and window will now be nil, so you know that you can stop any of your animations. So that was creating custom menu items. Really easy to do. It's the recommended approach, but sometimes that's not quite good enough. This is our example here with our custom suggestions example. We need something that acts a lot like a menu, looks like a menu, but is not in full control because we want the text to still be going to the text field as the user types. So the first thing we need to do when we're going to create our suggestion windows, we need to create a borderless window. Fairly easy to do. In this case, we have a custom subclass of NS window called suggestions window in the sample code. And we created a subclass for two reasons. First off, because Interface Builder, there's no checkbox or a series of checkboxes you can click to get a borderless window. If you have a subclass, you can set the class in Interface Builder to your subclass, which will force a borderless window property. But the main reason we did it in this sample code was that we're doing a unique situation here that we need to inform accessibility about, and having a custom subclass of NS window provides us the appropriate places to hook into that, and we'll cover a little bit of that later. And in this window, the designated initializer is init with content rect, style mask, backing, defer. So we're going to override the designated initializer, and when we call up to super, we're always going to send the NS borderless window mask as the style mask. So regardless of what's set in Interface Builder, when this gets called, we're going to create a borderless window. Or if you call it programmatically, you'll get a borderless window. And that's great. We get this, which isn't quite what we want. So we'll add some depth by saying set hash shadow. That's great, but we want the nice kind of rounded corners like a menu has, and we do that with a custom view that's set up as the content view for drawing. So we just need to tell the window that it has a clear background color. But then we get these black tips. We're getting a rounded drawing, but we have these black tips. And that's because the Windows server doesn't realize that this window has some transparency in it. It still thinks it's completely opaque. So we tell the window, set opaque no. And at this point, the Windows server does the appropriate compositing now, and we have a nice rounded cornered window that looks a lot like a menu. We're ready to add content. The next thing we need to do now that we have our window is we need to make our suggestion window a child window of the parent window. And this is really important. Why it's important is best shown when things go wrong. So this is not actually in the sample code, but I've modified it to do some things wrong here. So here we have the suggestion window is up. And if I go ahead and do expose nice and slowly, we see that our suggestions window kind of disappeared, and that's not what we want. And that was playing around with the window level there. Maybe we're going to change the window level to something else, and we get this when we expose. Whoa, now this is definitely not what we want. What is the user really going to be clicking on here? We don't want it. We definitely don't want that. So we'll go ahead and make it a child window, and when we make it a child window, you'll see that our suggestion window in expose will stay with our window, and it plays nicely and scales with the expose scaling. And if you were to try this with the suggestions list up in Safari, this is the exact same behavior that occurs. So that's the best we have. Now, what happened there? This is what happens if you aren't careful on how you deconstruct your child window whenever you go to dismiss it. I'll show you that again. It's now a child window, and it's doing the right thing. Great. But when I click anywhere that's going to dismiss this menu, the whole window went away. And if we look at the real example that you have in the code, as you've seen earlier. When this window is up, I can click here and it dismisses properly. So I'll show you how to avoid that mistake as well. So as I said, you need to add your suggestion window as a child window of the parent window. Parent window, add child window, suggestion window, ordered NS window above. So bring the child window above your parent window and be displayed, put it in the appropriate place. So now you don't need to call order front on the window, and we obviously don't want to make it key, so we don't want to call order front and make key, because the key focus needs to remain in the text field. And whenever the suggestions window is dismissed, and we do that in our cancel suggestions method inside in suggestions window controller, .m, in the sample code, the trick is to remove your child window from the parent before ordering out the child window. And our child window here is our suggestions window. If you order out a child window, it will automatically order out its parent window, and that's what was going wrong in that demo. So make sure you remove your parent-child relationship, then order out your child window. When do we want to activate our suggestions window? And how do we get that to work? So in Interface Builder, I went ahead and wired up the text field to the Custom Menus Application Delegate class, and I set it as the delegate of the text field. Then I went ahead and implemented the NSTextField delegate methods. In this case, control text did begin editing. The user started typing something. This seems like a wonderful place to go ahead and start putting up a list of suggestions. Control text did change. We'll probably need to modify our suggestions, or maybe we no longer have suggestions. We need to dismiss our suggestions window. Or maybe for some reason it was dismissed, and now we do have suggestions, so we need to make it reappear. Control text did in editing. We'll implement that one and dismiss our suggestions window because the user's either committed whatever they had typed or some other means canceled that, or perhaps key focus changed. So we'll need to go ahead and dismiss our suggestions window. And then last but not least, control text view do command by selector. If you remember earlier in our custom menus section of the talk, interpret key events calls do command by selector. And this is what's actually going on in the text field. And the text field then will go ahead and forward that on to its delegate via this control text view do command by selector. And the main reason we want to implement this is to search for the complete action. AppKit has an auto-completion mechanism built in whenever you're typing. And we need to suppress that because we don't want the auto-completion popping up on top of our suggestions, our custom suggestions window. And it's also a great place that we can catch this, suppress the auto-completion from AppKit, but use this to toggle the behavior that the user would expect. So when the user hits escape to do auto-completion, we can go ahead and drop down our list of suggestions. And when the user hits escape and our list of suggestions is already up, we can go ahead and dismiss that. Now, since we're simulating a menu, there's times where we need to go ahead and watch for the mouse and various other actions that go through the system and automatically dismiss our suggestions window. So let's take a look at some of those cases. So here we have a suggestions window up, and perhaps the user clicks into the desktop or another application. Obviously, we want our suggestions window to go away. You've already seen how the user can click in the parent window and it goes away. Here's an interesting trick. If I were to click on the menu here, the menu doesn't pop up because we don't want the menu to pop up. If I click again, the menu is going to go ahead and display. Or perhaps the user wasn't mousing at all and they did Command Tab and switched that way. So there we want our suggestions window to go away there as well. Or they did Command tilde to switch windows inside your application. So we need to go ahead and catch all those cases. But there's one other interesting little case, which is perhaps the user clicks in this text field. We still want that to work because we want to allow the user to be able to modify their selection so they can then go ahead and perhaps type an A instead and see the ladybug and the lavender. Just go ahead and select the ladybug. Peter has already talked earlier in the talk about local event monitors and when they are processed. And this is a great place for us to use it. It's a new, event monitors are new in Snow Leopard. So whenever we go to the show our suggestions window, we'll go ahead and add a local event monitor. And this is great because now we don't have to subclass NS application or NS window. So we'll add a local event monitors for events matching mask, and we're interested in any of the mouse downs, whether it's the right mouse button, the primary mouse button, or any other mouse button. And right in line, we can go ahead and add our code to how to respond to that type of situation. First thing we're going to do for our mouse down event is we're going to find out what window did this event occur in. Did it occur in our suggestions window? When it occurred in the suggestion window, we want to go ahead and allow the click to process through and allow that to act as an action. So we don't want to do anything. If it's not the suggestion window, then perhaps it's our parent window. Well, if it's not our parent window, this is a local event monitor, so it has to be some click that's associated with our application. And if it's not our parent window, it must be some other window inside of our application. So we'll go ahead and cancel our suggestions window. If it is on the parent window, then we have a little bit more work to do. You got a whole bunch of code here, and the whole point of this code is basically to find out, did the user click here? If the user clicked in the text field, we want to go ahead and allow that click to go through and be processed normally so the user can move the selection, change the selection, or just move the caret. All of this work is just basically doing normal hit testing, but the real key here is that whenever the user is typing in the text field, we actually place a field editor there. And so the hit testing will actually hit test to the field editor and not the text field. So we need to check the hit tested view here. If it's the text field or if it's the field editor associated with that text field, then we want to let the event process through normally. If it's anywhere else in our parent window, we'll go ahead and make event equal nil. This was the event that was passed into us in the beginning of our block. We're going to return that in a moment, and you'll see that. And this will effectively eat the event. So Cocoa will no longer route this event because we can modify the event here, and the event is eaten. But we'll go ahead and cancel our suggestions window, which will dismiss the window. And this is how we accomplish the user clicking on the pop-up button, dismissing the suggestions, but not having the pop-up button pop up. At the end of a block here, for completeness, you can see how we return event. And in this case, we will either always return the event, the mouse down event as it was passed to us, or we're going to return nil and effectively eat the event. So we set up our local event monitor whenever we showed our suggestions window. Likewise, we need to remove our event monitor whenever we dismiss our suggestions window. So event monitors are automatically retained, and the memory management is automatically already done for you. So when we add our local event monitor, we didn't need to call retain on it, but we did need to hang on to the observer so that we can call NS event remove monitor, and we can pass in that observer. Since we didn't retain it, we don't need to release it, but we're going to go ahead and make sure that we set our local member variable to nil because we don't want to hold on to an invalid object. So that handles a lot of the mouse cases, but the user can navigate with the keyboard, or perhaps something else like an alert pops up, and we want to handle that case. And that can all be done by listening for the NS window did resign key notification on the parent window. So this will handle all the other cases that we need to worry about. And you'll see that I'm using here the new 10.6 notification method, add observer for name. And that way this allows me to put right in line the behavior that I want associated with that, which is simply to dismiss our suggestions window. So we go ahead and we install a notification for NS window did resign key notification whenever we show our suggestions window. And likewise, whenever we dismiss our suggestions window, we need to go ahead and remove that observer as well. And just like the local event monitors, the observer that's returned to you, you don't need to retain it. The memory is handled for you. But you do need to go ahead and remove the observer, or else it's hanging around forever. And likewise, once you remove the observer, we need to set our local IVAR to nil. Otherwise, we're hanging on to a potentially invalid object. So that's great. So we got our suggestions window showing up. It's playing around nicely with the keyboard and the mouse and auto-canceling. But how did we get it to play nicely with the keyboard and the mouse as far as tracking goes? This turns out that it's very similar to what we're doing in our custom menu item view case. So I'm not going to go over that code here because it's practically the same thing. Please look at the sample code for some of the minor changes. But I do want to touch a little bit on accessibility. We're doing something a little bit unique here, so we have to inform accessibility of that. Cocoa does a lot of things for us, but what this looks like to the user is that there's a list of suggestions associated with a text field. In reality, we have a child window that's associated with a parent window. And we need to inform accessibility of the logical relationship that we have here, namely that we have a list of suggestions that are the child of some text field. So in the suggestions window class in the sample code, in the suggestible text field cell, in the suggestions controller, whenever we show the suggestions window, we go ahead and build this relationship. And whenever we dismiss the suggestions window, we go ahead and tear down this logical relationship for accessibility. I'm not going to go over the code, but real quick, in Interface Builder for that text field, I went down and I gave it a custom cell class, which is the suggestible text field cell. And this cell knows that it could potentially have a child window associated with it, and that's how we handle this relationship. Now we have a whole bunch of items on here, and we need to report to accessibility that this is an AX list. And we actually handle this in the rounded corners view. It's an NSView subclass that draws our nice rounded corners in our content for our suggestions window. But it will also report for us that that it contains a list of items to accessibility. There's not a lot of code there. It's in the sample code. And then we need to report that the image, the main label, and the blue label are all part of the same group. And we go ahead and we do that in the highlight view subclass. It's already had it there to handle the highlighting that you see at the top of the window as the selection is changed. So it's a great place to go ahead and report to accessibility that it contains a group, that all of its items should be considered part of a group. From there, the label views will report the appropriate things to accessibility, and that's great, but we still need to deal with this image. For an accessibility user, this image is just an opaque field unless we do a little bit of work. And in 10.6, we added an API to go ahead and allow you to do that. You can call set accessibility description. You can go ahead and put in a localized description there. In this case, we go ahead and put the file name since that's all that we know about it. If it's images in your application, calling set accessibility description will add a wealth of information for controls and displaying the intent to your users. It's real easy to do, particularly since we've also added that you can, if you're using named image whenever you create your images, you can actually just create an accessibility image descriptions.strings file and localize this file, and the accessibility description will be localized from this file and just added to the image automatically and then reported to accessibility. There was a good talk about this in the Cocoa Tips and Tricks, so I recommend you check out that session. So we've gone ahead and look at how key equivalents, they allow the user to accelerate their use of your application. So we've looked at how they flow through the system. We've looked at how the appropriate places for you to implement overrides or implement delegate methods to dynamically modify your key equivalents. We looked at how key equivalents and their conflicts are mediated by NSMenu and how you can even debug that. And then the last two items here, we've looked at how to create a custom view and put it in a menu. It's really simple to do. It's fairly easy. This is the recommended approach. As we change things in the operating system for the menu, you'll get the new look and behavior appropriately. But when that absolutely won't do and you have to do it yourself, you can look at the sample code and to see how we go ahead and we simulate the menu where appropriate and do all the appropriate things and the auto cancellation and attaching to the child window and working correctly with the system. For more information, you can see the Frameworks Evangelist, and there are a couple of links to our documentation. The forums are always a great place to get some more information and ask questions. The Cocoa Tips and Tricks session I referenced earlier, there's a lot of great information there, and went to a little bit more detail on some of the topics. And the Crafting Custom Cocoa Views, which was the session right before this one, hopefully you've seen that one, and if you're watching this on the video, you can go back and check that one out. There's some good information there as well that's related and a little bit more in depth on some areas that we've covered here.